Hi, in this video, I'll show you how to reclassify raster data into meaningful units. So raster reclassification is a method for aggregating data values into meaningful categories. For example, recall that a float 32 slope raster type can hold a huge number of different values. But to identify suitable slope for a vineyard, that's just too much detail. So we want to aggregate the data into ranges that mean something about vineyard location. So for slope and aspect, we're going to be reclassifying these into a range from 4 to 1, with 4 being the best for slope or aspect for a vineyard, and 1 being the worst for slope and aspect for a vineyard. We'll also reclassify land cover, and as for land cover, we're going to make that a binary raster, where suitable land cover types are equal to 1, and unsuitable land cover types are equal to 0. And that will become useful when we do the raster calculator analysis in the next video. So I'm going to get out of PowerPoint and into QGIS. So here I am in the QGIS project, and I'm going to switch to the processing toolbox, and I'll just type in reclassify, or at least the first few words of it, to narrow down the list of tools. That's always another useful way to find tools in the processing toolbox. And I'm going to be using the tool reclassify by table. So this tool takes an input raster layer, and I'll start with slope. And then we fill out this reclassification table. So I'm going to click the ellipsis button to the right of that and start entering rows. So I'll click add row, and I'll enter a minimum value of 0, a maximum value of 1, and this will produce an output value of 1. So what I'm telling QGIS here is that if a slope raster cell is somewhere between 0 and 1, the output value is going to be 1 for that. Okay, I'll move on to the next row. So I'll click add row, and I'll start where I left off in the previous with a value of 1 up to a value of 3. And the output value for this pixel range will be 2. And I'll continue until I have the completed table. Okay, so I've completed my table. So the most optimum range of slopes for our vineyard is going to be between 6 and 15 degrees. So that receives an output value of 4. And the most steep slopes and the flattest slopes will be the worst for a vineyard, so those get a value of 1. So when we do this, it's always important to click OK before you click the back arrow so it'll save this table. Otherwise, it will disappear. So we have a fixed table of 7 by 3. You can always go back into that and do some editing. If it's not expanded, you want to expand this advanced parameters section. And we want to set the range boundary. We want the min less than value less than or equal to max. And I'll check the box use no data when no range values match. And here there's no point in the output data type being a float 32 because we only have some integers. So I could change it, for example, to byte or integer 16. And I'll save the output into the same folder I've been working in, and I'll call it slope_RC for reclassification. That's just a little naming convention I've gotten into the habit of using. And naming conventions can be useful when you are going through an analysis and producing different intermediate data sets towards a final goal. And that way at least you understand what each raster or file represents. I'll click save, and then finally run to run the analysis, or the tool rather. So I'll go ahead and click close on this. And I can see I have my reclassified slope. Now I can go in and style this to make sure it looks correct. And so I'm going to use the paletted unique values renderer for this, since we have just 4 values in the output. I can click classify, and I can see the 4 values there, 1 through 4. And I can use the same red to green color ramp that I've been using so far, where green will represent the best values and red the worst. So here we have the slope classified from the best to the worst categories, and this layer is ready for the raster algebra in the next section. So I'm going to repeat this now for the aspect. So I'll open up reclassify by table, and this time choose aspect as the input layer. And again, I'll click my Fix Table button to set up the reclassification. So in this situation, the south-facing slopes are going to be most ideal. So I'm going to click Add Row, and I'm going to define south-facing slopes as those having an azimuth or aspect of 135 to 225. This will be kind of from southwest to southeast. So that'll receive a value of 4. Next, on the compass rose just north of there, from 90 to 135, will be a value of 3. And I'm going to have 2 3 values because I'm going to go east up the compass rose and west up the compass rose. So I'll click Add Row again and enter a value of 225 to 270. And that'll again be a value of 3 in the output. So I'll go ahead and fill in the rest of the rows. So I have my one optimum row, south-facing slopes, 2 rows for getting a value of 3 on the east and west side of the compass rose, east and west of south. Then I also have 2 rows that will receive a value of 2, which will be kind of the east and west facing, and then the northeast and northwest facing will be a value of 1. So I'll click OK to accept this. Again, I'm going to expand the advanced parameters section and set this min less than value less than or equal to max. And I'll use the same settings before. Use no data when no range matches value. I'll change the output type again to int16 and save the output. And here I'm going to use the same naming convention, aspect underscore RC. And I'll click Run to run the reclassification. So here is my aspect reclassified. And again, I'm going to go to the layer styling panel and use the paletted unique values renderer to see that this ran correctly. I'm going to use the same red, yellow, green color ramp and click classify. And I get my 4 values, 1, 2, 3, 4, representing the best aspects or directional slope for vineyard placement. The last thing we're going to reclassify is the land cover aligned. So I'm going to open up the reclassify by table one more time. Land cover aligned is the raster layer that's going to be the input, and I'll click Fix Table. So again, this is a categorical raster where we have values that represent different land cover types. And for the ones that are acceptable, we'll give those an output value of 1. For those that are not acceptable, we will give those an output value of 0. So I'm going to be listing all the different values in this raster and giving them either 1 or 0, depending on if they're suitable for vineyards or not. Okay, so the 2 that are suitable, codes 30 and 40, representing grassland and cropland respectively, will receive an output value of 1. The remaining land cover types will receive a value of 0. And for each one, I've just set the min and max to the same value of that land cover class. So I'll click OK to accept this. Here I want to change the range boundaries for what we've used so far to less than or equal to value less than or equal to max. And that's simply because we have the same number for the min-max of every row. Change the output to int16, and I'll call this land cover aligned RC. Click Save, and I'll go ahead and run the tool. Close when it's finished. And here's my land cover aligned. And again, we'll go back and style this with the paletted unique values renderer. Click Classify. We just have 0 and 1s. For this, I'm just going to select the 0 class and remove it and just style the 1s as green. So we're just now looking at the portions of the land cover which are suitable. Now I can see the areas of the map that are containing suitable land cover, and the holes in this layer would be the unsuitable land cover. Using this renderer, if you always want to add those back, you can always click plus, add that 0 value, and make those red to show the unsuitable areas in red. Okay, so that's how to reclassify rasters, and in the next section we'll be combining these rasters to actually conduct the analysis using the raster calculator.